in chapter 11, we will work on alkynes, another category of hydrocarbons. And after studying alkenes, studying alkynes makes more sense and must be easier. So let's just learn some facts about alkynes. First of all, the formula for alkynes, general formula, is CnH2n minus 2. You remember, for alkanes it was CnH2n plus 2, for alkenes CnH2n. Now we reach to alkynes, CnH2n minus 2. So from alkane to alkenes, 2 less hydrogens, alkenes to alkynes, 2 less hydrogens. So that's the general formula. That's the first thing you need to know. You must know about them. If you consider the simplest alkyne, first of all, alkynes have triple bond between the carbons. This is the simplest alkyne considering the octet of carbons. So the bonding angle around triple bond is 180 degrees. The hybrid on the carbons of triple bond is sp. Why? Because if you remember, we said in order to calculate the hybrid, to determine the hybrid, we just count the sigma bonds. In each triple bond, there is 1 sigma and 2 pi bonds. So we never count pi bonds for hybridization. How many bonds do you see around each carbon? 2 bonds, one of them is S, the remaining is P. So the hybrid is sp. The bonding angle is 180 degrees. Whenever the bonding angle is 180 degrees, the molecular shape is linear. So the shape around triple bond is a linear shape. Now, let's talk about the nomenclature. Now you know naming alkanes, then alkenes. Now naming alkynes is easier with some twists, but you know the basics. Nomenclature. So let's start. First of all, we stick to the rule of the longest chain that contains triple bond. Longest chain is not necessarily the straight chain. So for example, we have this and we have a triple bond. This is how we show it as a skeletal structure, or we can also show it as 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. So it's either this or this. I mean, if you see it in a straight form, means that you need to count the 2 carbons on the 2 sides of triple bond. Alright, so here there is no branch, so we just determine the location of triple bond. From left to right is closer to triple bond. So there are 2 ways you can name this compound. First, you can mention the location of triple bond. Where is it? Between the 2 and 3. So we always number the one which starts triple bond. So it's 2. How many carbons? 7. If it was an alkane, it would be heptane. Now it's an alkyne, so it would be heptyne. 2 heptyne. It shows that, first of all, this is an alkyne composed of 7 carbons, and this is the location of triple bond without any branches. Another way of numbering is you bring the root for the name, hept, and then 2, then ein. This is the newer type of name. This is a newer method of naming. You need to know both. So either bringing the number first, the number of triple bond, then the root hept, and then add wine, or bring the root first. The root is hept. Then you bring the number where the triple bond is located, and then triple bond is expressed as wine or ine as alkyne. Okay, so make sure you know both. An example you have here, we are supposed to draw 2-methyl 3-heptine. 2-methyl 3-heptine. Don't forget there should be a dash between every number and letter. 2-methyl 3-heptine. So first of all, when we go from name to the formula, to the structure, we need to look at the ending. First of all, ine shows it's an alkyne. Hept means we have 7 carbons. 3 means this is the location of triple bond. And this shows the branch. Okay? So first we build a 7-carbon hydrocarbon. 1, 2, 3, 4, 5, 6, 7. Then now we have on the third carbon, let's number them. Right to left or left to right, doesn't matter. On the third carbon, between 3 and 4, there is a triple bond between 3 and 4, and there is a methyl on the second carbon. So it's 2-methyl 3-heptine, or you could have named it as 2-methyl hept 3-ine. Okay? Now, let's move to next rule. This was pretty straightforward. What you had in alkenes can apply on alkynes as well. What if we have 2 triple bonds? Remember, for 2 double bonds, you call them diene. 2 double bonds, right? Now, for 2 triple bonds, you call them diene. Right? Means 2 triple bonds, 2 double bonds, 2 triple bonds. So let's say we have 2 and 5 octa diene. So you see, when you want to bring to write the name of the diene, you bring the root and then diene. If you have 3, you would put triene instead of 2-ine. So means that we have an 8-carbon structure. So let's draw the structure. 1, 2, 3, 4, 5, 6, 7, and 8. Where are the 2 triple bonds? Between 2 and 3 and between 5 and 6. So we number it first. 2, 3, 4, 5, 6, 7, and 8. The first triple bond between the second and third. The second triple bond between the 5th and 6th. That's our 2 and 5 octa diene. And the last thing you need to know is, what if we have a combination of double bond and triple bond? We need to start numbering from closer to the multiple bond. Number from the end closest to first multiple bond. Either a double bond or triple bond. Like for example, if you have this compound, which side numbering is closer to the first multiple bond? Of course, from left to right, because your triple bond gets number 1. If you start from right to left, then double bond gets number 3, which is not desired. So you will number from here. You would say 1. How many carbons do we have? 6. It's 1 and wait a minute. You bring the in for double bond before ine for triple bond. Why? Because of E comes before Y. So you number from closest to the first multiple bond, whether it's double or triple, but number name the ene first. Where is the double bond starting? The third one. So it's 3. How many carbons do you have? 6. If you did not have triple bond, it would be hexene. But since you are going to continue, eliminate E. So it's 3 hexene and 1 ine. So seems like your double bond is carrying most of the name, and that's true. Double bond has priority to triple bond because of its alphabetical order. So one more time, the rule is number from closest to the first triple bond, whether it's double or to first multiple bond, sorry, whether it's triple or double. Here we are closer to triple bond, but don't forget, we always say in naming we start with the alphabetical order first. So for double bond we have ene, for triple bond we have ine. E comes before Y. So we say we have to mention the location of double bond first. Where is it? Between 3 and 4. So it's 3. If we did not have a triple bond, we wanted to just name it as an alkene, we would say hexene. But whenever in any of these carbons, whenever we need to continue after the name of one of them, whether it's alkene or alkyne, we have to eliminate the E at the end. So it's 3 hexene. You also pronounce it as 3 hexene. And you need to mention the location of triple bond between first and second carbon, so it's 1 ine. If the location is the same from both sides, location of triple bond and double bond, because double bond comes alphabetically prior, you also number from alphabetically prior side. You have a tie, right? Either way, if you start from right, double bonds falls on the first carbon. If you start from left, the triple bond falls on the first carbon. So because the ene for double bond is alphabetically prior, so you start from right to left. So you have 1, in this case you have 1 hexene, right? You eliminate E because you were putting a dash after it. And then where is the triple bond? 5 ine. Don't forget dash between every letter and number. So that's how you can draw 1 heptene 6 ine that you have on your study guide. Now let's work on some of the examples given to you in the book and study guide also. Study guides from the book, so I know that you have the solutions, but let's work on some of them together because some of them may look weird. All right. First, what is the first rule? What is the first thing we need to do? Is to take care of the longest chain, which is not necessarily the straight chain. So this longest chain must include triple bond. So it's obvious that we need to start from here. And don't forget I said there are 2 carbons, 1, 2, and then 3, 4, 5. Now you have a choice. 5, 6, 7, 8, 5, let's number them. 2, 3, 4, 5. You have 6, 7, 8, 6, 7, 6, 7, 8. So it seems like they're going from this way or this way is the same, so why not going towards the right side? Okay, now let's take care of the numbers. 1, 2, 3. Seems like I made a mistake. Sorry, I have it here on terribly sorry about that mistake. So you have 5, 6, and 7. Any way you go, any way you go. So you, I don't know what's wrong with me. I drew it all wrong. Okay, now. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So we go with either this way or this way or this way. So we have 2 propyls here, and either way we have 2 propyls, doesn't matter which way you go. So let's number it from here. If in the book you see it's numbered from here, they're the same. So let's number the branches. They're all propyl, right? Both of them. On which carbon? On the 4th carbon. So it's 4 and 4 because I see 2 propyls. So it's dipropyl. Don't just put 4. 4 and 4 because we see 2. As soon as you repeat the number, you need to have the prefix di. It's not 4 and 4 propyl. It's 4 and 4 dipropyl. And let's take care of the location of triple bond where? On the first one. So you can say hept 1 on, right? The longest chain is hept 7 carbons. And then you put the dash 1 on, means the triple bond is on the first carbon, between the first and second carbon. We could have also said like 4 and 4 dipropyl, one heptine. I mean, either way. I told you this is the newer method of naming. I would work on C as well. I'm sure you can use your knowledge for naming B and D. So we have 1, 2, 3, 4, 5. Okay. So here's our structure. Should be careful not to make the mistake again. So now we have double bond and triple bond. We need to start from closest to the first multiple bond. Which one is the closest? Left to right. 1, 2, 3, 4. Don't forget, carbon number 5 is here. Carbon number 6 is here. 7, 8, 9, and 10. So, what are the branches? We have 2 methyl groups here. And we have an ethyl group here. So which one comes alphabetically first? Ethyl, of course. 4 ethyl. How many methyl groups do you have? 2. On what? On 7. So it's 7 and 7. Dimethyl. Right? Dimethyl. Now, how many carbons we have? 10. So dic. 1 in when you have the combination of double bond and triple bond. Or you could say 1 decen. Dec, 1 in, and you have the triple bond on the 5th one. Or again, you could have said 4 ethyl, 7 and 7, dimethyl, 1 decen. Don't forget, you need to eliminate E, as you see here. 5, sorry, this should have been 1. 5 wine. So these 2, both of them are correct. Either sticking with the rest of the name, the root, and then number, and then N, and then number I, or you separate the decen from the rest of the name. It's up to you. So work on B and D. They're very similar to each other. Another point, another another bullet point about this naming is that, like, let's say we have this compound. What do we see? We see triple bond outside the cyclic compound, right? And obviously you cannot have a ring with a triple bond, otherwise you will violate the octet rule. So this is one, this is two carbons, right? In this case, the carbon that carries the triple bond would be carbon number 1, and then you go around this the ring with the way that is closer to the branches, if you have any branches. But the carbon that carries the carbons of triple bond will be the first carbon. In this case, because triple bond is not a part of the longest chain, because longest chain has 5, then you treat it as an alkyl group, as a substituent. So how many carbons do you have here? 2. If it was by itself, it would be called ethine. It comes from ethane, right? So what do you see on the first carbon? 1 ethynyl, ethine, you remember methyl ethyl? So this is ethynyl because that's the alkyl group from ethine. Ethynyl. 2. What do you see on 2? The V-shape substituent is isopropyl. Isopropyl. And what is our main structure? Is a cyclohexane, right? Cyclohexane. So watch out for the triple bonds outside the rings. So if you want to work on going from name to draw it, we have trans 2 ethynyl, cyclo, pentan, ol. Ol means we have an OH group, it's an alcohol. And ethynyl means we have a ethynyl group connected to the rest of the molecule. We have a cyclopentane also. Oops. So let's draw a cyclopentane. So it says ethynyl is on the second carbon. So there should be a first carbon, right? So let's put the ethynyl. What goes on the first carbon? Ol. But be careful, we have OH on the first carbon because OH has priority to multiple bonds, whether double or triple. Learn it now because you will work more with the alcohols in organic too. So OH, alcohol, functional group has priority to double or triple bonds. Now, OH gets the first, sits on the first carbon, ethynyl sits on the second carbon, and you have a trans. So you need to show the stereochemistry, whether show OH on the wedge and ethynyl on dash or vice versa. It's the same. You can have OH on the dash and ethynyl on the wedge. Doesn't matter. Let's work on C. I'm sure C is a little bit different than B. B is just a straight chain. C is 3 and 3 and 5. Tri, methyl, cyclo, no9. The challenge is to put the cyclo-no9 with 9 carbons, that's all. So 1, 2, 3, 4, 5. Oops, it looks like a Christmas tree, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. So let's number them from here. 3, 4, 5, 6, 7, 8, and 9. On the 3, we have 2 methyl groups. On the 5th carbon, we have the 3rd one, right? Because you have total 3, and on 3rd carbon, you have 2 of them. The last one falls on the 5th carbon. Cyclo-9. So you would say, okay, where is a triple bond? Don't forget, since there is no other functional group, the triple bond will be on the very first carbon and the 2nd carbon. So if I told you that triple bond cannot be inside the ring, that's not true, because you can have the triple bond without have the hydrogens. I should have told you there would be no hydrogen, not there would be no triple bond. So that's as far as the nomenclature of alkynes. You already learned how to synthesize alkynes when you were in alkene chapter. So synthesis of alkynes is very familiar to you through elimination reactions. Elimination but from what? Elimination from dihalides. From dihalides. You definitely must have 2 halogen atoms on the in the compound. So I go with the same examples, general examples you have. You have some carbons and hydrogens that you show as R. Then you have hydrogen and halogens on the 2 adjacent carbons. You call it vicinal dihalide. When the halogen atoms are on the 2 adjacent carbons, you call them vicinal dihalides. Through an E2 reaction with a base, the best base is NH2, one of the best bases. So what happens is that the base grabs hydrogen, the electrons fall, and the halogen in the anti-position. Remember, for E2 you must have an anti-position, hydrogen and halogen. They eliminate, so you will have, for this step. Now, suppose you have extra base in your solution. So another elimination happens to form triple bond, and the same mechanism. Hydrogen will be grabbed by the base. The electrons will form a triple bond, and the halogen in the anti-position will leave as the leaving group. So another E2 reaction. So in order to form the alkynes from dihalides, you need to have 2 E2 eliminations back to back, but we must have halogens and hydrogens in the antipositions of the halogens. So you will end up having this compound. And the same thing when your halogen and are on the same carbon, and you also have an adjacent carbon with 2 hydrogens. So you call it a geminal dihalide this time. We said we must have a dihalide, so we can have 2 types of dihalides, a geminal and a vicinal. Geminal carries the halogens on the same carbon, and the adjacent carbon must carry 2 hydrogens. These are the conditions for this elimination. So one of the hydrogens will be deducted through an E2 reaction. One of the halogens, which are definitely in the antiposition, will leave. So you will end up having an alkene again. Now the second, again, excess base. You definitely must have an excess base, hydrogen and halogen in the anti-position to help you with the second elimination reaction and formation of an alkyne. We're not worried about the byproducts. We just focus on the formation of alkynes. So this is the major procedure for formation of, for synthesis alkynes. The best bases, as you saw, NaNH2, that we just work with the NH2 part, and also a bulky base, KOC third, which has some third butoxide. These are the best bases that can do this A2 reaction. All right, in the next video, we will talk about the reactions of alkynes.